Hello and welcome to the EEPROM 9, and here we have a Kaypro 2. This is actually on the holy grail list of computers I would love to acquire. This one isn't mine, this one belongs to Look Mum No Computer, and I'm currently fixing it because I volunteer at his museum, and he won it in a bidding auction. I forgot to put a bid on this, but it turns out that it didn't matter because I get to play with it anyway. But it has a problem, because every good computer has a problem. When we turn it on, apart from the usual 15 kilohertz high-pitched squeal to ruin your ears, we have screen corruption. Doing some research suggests that it's either the video ROM or the RAM. In this case, it looks to be both, and I'll tell you why. So you can reset it to the point it does disappear, which is interesting. At the museum, it was even more garbled, like completely over the screen. It's very inconsistent how garbled it is. Then the garbling will come back. Always at that top corner, interestingly. But let's put that in the EEPROM programmer and do a little verify on it, and you'll see what I mean about the ROM actually having a problem. Where are my chip pullers? There they are. This is where proper YouTubers use actual capture software, not me. But we have a copy of the actual ROM image here. And when we do a verify from the EEPROM, we get this. Every time we verify it, we get a different result of how many differences. 30, 32, 22, 27. Yeah. And then when we go to the EEPROM I've written with the same technique I used for the Acorn System 1, where I put 24 volts on the VPP pin, bent it out and disabled pin select. So that's the original EEPROM. There's a website. I'll put links in the description to like the websites that have the ROM images and whatnot, because it was a bit of a palaver to find. But luckily the information is out there. And then if we go verifying this one, first off, we don't get that stupid pop-up message, and we get succeeded every time, indicating that, yeah, the EEPROM's not the main cause of the problem, but it is part of the problem. So next part is to just dump in the new EEPROM, which I've programmed, which works, verified, all that good jazz. Switch it on. Wait for the CRT to come into visibility for us, and bam! We have screen corruption. Although, you might notice it looks slightly different, but there is some very defining characteristics. Always focuses on the bottom. Also, same thing to clear it, to eventually clear it. And just as temperamental. And boom, not a good fix. Another thing I discovered was this was when I was at the museum, the 74LS00, which I think is a quad AND or NAND, I think it's a quad NAND, had its very back pin, wouldn't be 8, pin 9 was bent over, so I popped that back in. If you remove that chip, the display doesn't work at all, so this is obviously used as part of the logic for the actual display. But yeah, the next thing to do is desolder these RAM chips and stick them in sockets, and then from there we can fix it. We can actually put in new RAM chips when I acquire new RAM chips. RAM is socketed. Woo! So after a bit of debugging and probing around, we're popping around with these RAM chips, because that's where the problem was in the video circuit. Now we got the ROM replaced and stuck on the old sticker because the ROM was partially corrupt. I ended up swapping around the ROM chips, and the symptom was basically the garbled crap was still at the bottom of the screen. So I then started removing them. And it was interesting. When I removed this RAM chip, I got this. So we turn it on. I've got a disk drive in the disk, which is why it stops, because normally it stays on permanently. We got this screen, but the garbling twinkly had gone. But any time I did the same, but with any other chip, it would do all this. Get different types, corruption would look different, but you get rid of the twinkly stuff. So the problem was always focused in this bottom socket. The other thing I did was I tested the RAM chips. This is a simple little tester that basically flashes between the red and green to indicate it's testing, and then will either flick to one of the two states when the RAM chip either passes or fails its test. In this case, you'll see in a bit, it will swap to, it will go on to staying on to permanently green, which we'll let it do on video so you can see that it passes the test. It's a little Arduino thing, so it wouldn't be hard to reverse engineer one of these and just pull the code off and stick it on. I could definitely do with a few more of these, but yeah, this is a specific 2114 RAM tester. But yes, flicked on solid green. So after that, it was a case of, well, what was it? Because I don't really have a schematic for the board, and there's a lot of different board versions of the Kaypro computers. So then, well, my partner Ash was probing around at all this and pulling out the scope, and picked up something very interesting with the scope. Let me just set up the scope. So I did all the usual testing, you know, testing the crystals, testing the voltages. They're all coming out correct and working, even though that crystal looks a bit rusty. But you won't see it now because I've repaired the issue. But as I was going through the various pins, if my scope would work. It generally helps to turn things on when you're doing testing. Remember that. So, you know, you got your power, you got your data, you got your data. These are all the address pins. Most of these things are address pins. Data. Then we got the data pins, which are the final four, because these are 4-bit chips instead of the usual 8-bit chips these are. Then you got more power. Then you have this interesting pin. Now this was the one that had the problem, because all these ones, they're all common together, and they all have the nice little clock signal. A little clock going into them, which is running at 180 hertz, you know, data signal. Go back down the addresses, and they were all fine.
What one you got?
But the thing that was really interesting was, and then that's just negative. The thing that was real interesting was all these pins on all these other chips were lighting up like that. However, when I put it in this one, I fixed it now, so it's lighting up. I was getting nothing. Yeah, so I thought, solder bridge.
So you've got next valve open there as well.
So that's what we did.
I've got
we soldered and we took out the board, soldered a little solder bridge from here to here, and there's also a little wire that takes off to one of these chips out here. So this is all part of the video generation circuit here. And then, where did I put the chip? It's still in the tester.
2 extruders on it.
We'll pop our little microchip in. And we marked the pin with a little thing to show which pin was dodgy. And then we turned it on, and watch this magic.
Yeah, I messed up the thumb.
As it fades in, the screen corruption is fixed. I still have the issue of successfully writing a CPM boot disk though, but that'll come. But yeah, hey presto, we fixed the Kaypro. She's all good to go. I also off-camera ran a service of the disk drives, which if I remember, I'll put a link where I did this IBM disk drive that's not down there now. But I did an IBM 5160 video, which is like 20 minutes long, of like going through the servicing process of one of these, which is basically the same. I just did it twice on these. One thing to note, these are single-sided disk drives, and the reading side is on the bottom of the disk. So you can, if you want to, do the classic old use the discs kind of thing. That was a classic thing they did back in the day. Although you do need 2 of these holes for that to work properly. Otherwise the drive can't read the RPM. But yeah, that is how I fixed it. And that was an absolute arse of a problem to track down, as often they are. It was simple. A trace had failed. You know, number of factors. ROM had got bit rot, trace had failed. I should actually download an image and verify. Actually, I'm going to verify this EEPROM as well, just to double check. And if that doesn't work, I'll replace that before I button this thing back up and put it together. So I'm gonna go do all that now, and next time you see it, you should see this thing put together. And so here we have the beloved Kaypro. We've put the disc in the drive so it can fail to read it. I might actually try using one of these drives, but they're a bit of a bugger to get out. Turn it on, keyboard all connected. Oh, hello, it beeped. That's the first time it's beeped. Does it actually type anything when I do this? No, it doesn't, but it does make beeping noises, which is good because we can test it. We can test all the keys. But yeah, the ROM chip turned out good. I'm not going to make you watch me go through the testing of the key process, but yeah. The numeric keypad works. Yeah. This is obviously who owned it, because Look Mum No Computer got this in a auction thing. I was going to bid on it as well, but completely forgot about it. But hey, I got to play with it anyway, and I volunteer at the museum, so I get to play with it anyway. So at least one of us got it. So yeah, that's all for now. Thanks for watching until the next random retro computer restoration project comes along. Because now I actually have a source of retro computers to play with, despite the fact I've lacked out of space for many more retro computers. I can still get to play with them and do the bit I like, which is restoring them. Without having... Yeah, I would love to have space for machines like this, but I don't. Anyway, so this will go back to the museum when the COVID's been and done and we can actually go back and all that good jazz. And then other people will work on it, on making discs and whatnot. But I'm rambling. Thanks for watching.